In this video, we'll be learning about cloud defense in depth. I am Chris, cloud architect and founder of systemsarchitect.io and codeguides.io. And check those sites out. Defense in depth means stacking independent security controls so one failure cannot take down the whole system. A bad firewall rule should not dump your database. If segmentation, encryption, and access checks still stand, this checklist covers 10 principles for layered defenses across AWS, Azure, and Google Cloud that still hold when single controls break. You will hear about trust boundaries, identity plus network plus host, multi-control failure design, encryption, per layer logging, and more. Use this when you design a landing zone, review an architecture, or fix a stack that still hangs everything on one gate. 1. Layer security at every boundary. 2. Combine identity, network, host controls. 3. Require multiple controls to fail. 4. Protect data at rest and transit. 5. Monitor and log at each layer. 6. Apply WAF plus IPS plus endpoint protection. 7. Use different vendors when possible. 8. Never rely on single control. 9. Test layered defenses together. 10. Document all defense layers. This is a condensed version of the full article on blog.systemsarchitect.io. View more details there. First, layer security at every boundary. Internet to CDN and web application firewall, then load balancer, then app, then data, each need their own rules. If only the API gateway enforces access, one misconfig exposes everything behind it. Map public DMZ application and data zones and put at least 2 independent controls on every boundary. DMZ means demilitarized zone, a buffer network segment that isolates public-facing services from internal systems. On AWS, public subnets for load balancers, private for apps, isolated for databases, plus NACLs, security groups, and VPC endpoints. NACL, sometimes called NACL, is Network Access Control List, a stateless rule set that allows or denies traffic at the subnet level. VPC, of course, refers to Virtual Private Cloud, an isolated virtual network within a cloud provider. On Azure, tiered subnets with NSGs, private link for PaaS, and application gateway with web application firewall in its own subnet. PaaS is platform as a service, a cloud model that provides a managed platform for building and running applications. On Google Cloud, tag-based firewalls, separate VPCs with peering rules, and private Google access without public IPs. Second, combine identity, network, and host controls. Who is calling, where traffic comes from, and what the process can do on the host are 3 different failure modes. Network alone fails against a compromised insider. Identity alone fails on a flat network with a stolen service account. Host hardening stops exploits when the other 2 slip. For every workload, require at least 1 control from each category. For a container API, that means IAM roles, identity and access management roles, network policies or security groups, and read-only root with dropped capabilities. Audit all 3 dimensions quarterly. On AWS, blend IAM least privilege, security groups, IMDS v2, and for ECS or EKS, network policies plus read-only routes. IMDS v2 is Instance Metadata Service version 2, a hardened method for cloud instances to retrieve their metadata securely. ECS refers to Elastic Container Service, AWS's managed service for running containers. EKS is Elastic Kubernetes Service, AWS's managed Kubernetes offering. On Azure, use Managed Identities, NSGs, Policy for Host Config, and on AKS, Workload Identity with Calico and Pod Security Standards. On Google Cloud, use Workload Identity, tag firewalls, gvisor sandbox, and binary authorization for signed images. Third, require multiple controls to fail. Think Swiss cheese. Holes exist, but they should not line up. Web application firewall bypass, rushed IAM, or open ACLs alone, access control lists, must not equal a breach. Two independent controls at roughly 99% each stack toward much higher combined odds. Tabletop your top three assets and ask what still stops the attacker if control X is gone. If nothing, add a compensating control. Protect S3 with bucket policy, VPC endpoint policy, and object lock. Protect Azure SQL with intra-auth, private endpoint, and TDE transparent data encryption, a feature that encrypts database files at rest without application changes. With customer managed keys. Protect cloud storage with IAM conditions, VPC service controls, and customer managed encryption keys so even bad IAM still faces a perimeter and locked keys. Fourth, protect data at rest and in transit. Stolen disks, shared snapshots, or sniffed traffic should yield ciphertext, not gold. Is strong encryption expensive? Modern AES 256 hardware crypto is cheap, under about 2% CPU, and required by major compliance regimes. Turn encryption on by default at org level and deny unencrypted creates with SCPs, Azure policy, or organization policies. Default EBS encryption, S3 encryption, RDS at create time, and TLS only listeners on AWS. Azure Storage and SQL already encrypt at rest. Enforce HTTPS only on app service. Google encrypts at rest by default. Use CMEK and shielded VMs where you need tighter control, with ALTS on internal Google paths. Fifth, monitor and log at each layer. App-only logs miss network scans. Network-only logs miss business logic abuse. Why watch every layer? Multi-layer monitoring can cut time to detect dramatically versus a single lens. Ship network, identity, app, and data logs to one SIEM, Security Information and Event Management, a system that correlates security logs to detect threats but tag the source layer and correlate, for example, failed login, then odd API calls from a new IP. On AWS, enable CloudTrail, VPC flow logs, and guard duty, optionally into Security Lake. On Azure, send diagnostics, NSG flows, and sign-in logs to Log Analytics and Sentinel with UEBA, User and Entity Behavior Analytics, analytics that flag abnormal user or system behavior. On Google, enable admin and data access audit logs, sample flow logs by risk, and feed Chronicle for long hot retention search. Sixth, apply Web Application Firewall plus IPS plus endpoint protection. Web Application Firewall catches SQL injection and cross-site scripting in HTTP. IPS catches network exploits and anomalies. Endpoint agents catch malware and bad processes on the host. What if you deploy just one? Each alone leaves a large hole. Together, they cover most common patterns. Put Web Application Firewall at the edge, IPS inline or via mirror at the VPC, and agents on every instance. Keep managed rules fresh and accept useful overlap. AWS Web Application Firewall with Network Firewall, Suricata, and Guard Duty runtime monitoring is one stack. Azure Web Application Firewall with Firewall Premium IDPS and Defender for Servers is another. IDPS is Intrusion Detection and Prevention System, a control that both detects and blocks network threats. Cloud Armor, Cloud IDS, and a separate EDR agent close the same triangle on Google Cloud. EDR refers to Endpoint Detection and Response. host-based tooling that detects and responds to threats on devices. Seventh, use different vendors when possible. If Web Application Firewall, IPS, and EDR share one engine, one bypass can punch every layer. You do not need a unique vendor everywhere. Diversify the critical layers. Native Cloud Web Application Firewall, open source or different IPS, specialized EDR, AWS Web Application Firewall, plus Suricata on Network Firewall, plus CrowdStrike on hosts is a clean three-engine mix. Azure Web Application Firewall with Suricata or Snort NVAs and a non-Microsoft EDR works the same idea. NVA is Networked Virtual Appliance, a virtual machine that runs network functions like firewalling or routing. Cloud Armor with Palo Alto-powered Cloud IDS means pick a non-Palo Alto endpoint tool to keep diversity. Eighth, never rely on a single control. Every control has a failure mode. Misconfig, social engineering of MFA, leaked keys. If that one control is the whole story, the blast radius is the whole asset. For each critical asset, list controls and ask the full failure blast radius. If too high, add compensating layers like conditional access behind MFA or app auth behind firewall rules. Pair security groups with NACLs and IAM. Pair NSGs with Azure Firewall, conditional access, and PIM privileged identity management, a system for granting and auditing time-limited elevated access. Pair VPC firewalls with ORT policies, IAM conditions, and service controls. PIM refers to ninth test layered defenses together. Controls that pass unit tests can still leave gaps when decode order, autoscale placement, or rule interactions misalign. Quarterly red team style chains from recon through exfiltration show which layer detects and which blocks each phase. Anything neither detected nor blocked is a hole. Map cases to Mater at T and CK in tools like Atomic Red Team. Use Scout Suite, Prowler, PACU, and Platform Rules of Engagement to validate Guard Duty, Sentinel, or Chronicle actually fire on simulated abuse. 10th, document all defense layers. Ops, security, and developers need a shared map of what exists, where it lives, and how layers interact. Why document defense layers? Undocumented rules get deleted as noise during incidents or refactors, sometimes removing the only lateral movement block. Keep a security control matrix per asset covering network, identity, host, data, and monitoring, ideally as code next to infrastructure, and updated in every design review. Security Hub, Defender for Cloud, and Security Command Center help inventory live controls, tag resources by purpose, and layer for queries. To close, put independent controls at every trust boundary and always mix identity, network, and host. Encrypt everywhere and log each layer so stolen bytes are useless and weak signals become strong when correlated. Stack Web Application Firewall, IPS, and endpoint from different engines so one trick is not enough. Test the stack as a system and keep the matrix current so defense in depth survives change and pressure. Do those 10 practices and single failures become contained events instead of full system breaches. Thanks for checking this out. Hope you learned something. Find a lot more articles and guides on both systemsarchitect.io and codeguides.io.